One of the share with me, please. Can't remain at rest under action of any shear force. Fluid is a substance which offers no resistance to change of
shape.
Raise your voice, please. Shape.
Yeah.
Units. I think I focus for this one for the introduction. I tell you 1% from the total. So here I just focus for some small items for the units. First we start, for example, for length, for a size meter. Here it's feet, and sometimes it's inch. Be aware for the change from inch to feet, divided by 12 for inch to change to feet. Mass is kilogram, and for bridge is slag and pound mass. This is very important. And to change it from slag to pound mass, one slag is equal. Close one, please. When you're going to share with one
voice is not clear, sir.
32.2 pound mass. You tell him something?
Yeah, there is a lots of
One slug
disturbance.
equal to, sir?
Again?
There is a lots of disturbance. Can you mute rest of the
Yeah,
participants?
this is what I inform these all engineers. Close mic. You can open mic when you're going to share with us for question, or if you have any question. Otherwise, you can close mic. This is as a normal close. Okay. So one slug is equal to 32.2 pound mass. Temperature here is Celsius. This is Fahrenheit. The scale absolute for this one is Kelvin. The absolute for Fahrenheit is Rankine. Time is the same second. Force is 1 Newton, which is equivalent to kilogram meter per second square, because as you know, the force is equal mass times acceleration. For British, pound force equal to 1 slug feet per second square. So slug is mass, and this is acceleration, and is equal to 32.2 if you use its pound mass unit, feet per second square, because as we know, 1 slug is equal to 32.2 pound mass. Gravitational acceleration G, which is equal to 9.8 meter per second square, and here is equal to 32.2 feet per second square. As we all solve this one value 9.8, so save also this value 32.2. Energy 1 joule, which is equal to 1 Newton per 1 Newton meter, because as we know, the energy it is equal force times times distance. Here is BTU, or bound force feet. Bound force feet. Power is 1 watt, which is 1 joule per second. Here is horsepower, and we can change horsepower to watt, and we can change it also to feet bound force per second. Okay, so this is important. 550 feet bound force per second. This is equal to 1 horsepower. This is some important units accumulated here. So just check for this all, and also we can check a lot during the solving for many questions. Velocity. Velocity is rate of a change of distance. Acceleration, rate of a change of velocity. Force is mass multiply acceleration. Weight is mass multiply gravitational acceleration. So weight is by default is a type of force, but it is acceleration here is special acceleration, is gravitational acceleration. Also, the weight is all the time is downward. All the time is downward. Work is force multiply distance, and this force here is a mandatory to have a work. Also, the distance is a mandatory to have a work. So if you have a body and you apply a force by this body, but there is no distance or displacement happen, so there is no work, even you have a force. If you have distance displacement happen without any force applied, so this also again there is no work. So we have two conditions to obtain a work. Power is the rate of work. That's it. Mass density. Mass density is equal to mass divided volume. What's mass density? Rho density is equal mass divided volume.
Excuse me.
Okay,
Work.
yes.
Work is F multiplied by X. X is a
Distance.
distance. And it's Newton meter, the unit.
Yes.
Or Joule, equal Joule.
Yes.
Joule is the British, yani.
No, SI.
This is I. So Newton meter also.
Yes, it is British. This
Mhm.
energy. This force.
Mhm.
Okay. If
BTU pound foot.
feet per pound force.
Multiply by 1/4.
Yes. Specific weight is equal to rho g. Density actually is a property. This property for the material or any fluid. So specific weight also is a property. Because it's coming from property multiply constant, so it is property also. This is specific weight, gamma. Specific gravity very important. Why is it important? Because for fluid mechanics problem is normally given S, not given gamma, not given rho, so given normally S. And from S you can calculate the gamma for the fluid. What is equal S is equal gamma for fluid by gamma of water, which is mean normalized the gamma of the fluid by gamma of water, which is equivalent also rho of fluid by rho of water. The same meaning. What I mean for this, I'll give you a simple example for that. If I give you Cg for the oil, for example, is 0.7. So it means gamma water is equal 9810. So what is means this one? The gamma fluid, gamma water is equal 0.7, which is Sg. What's referred here for fluid? This is oil actually. So it means gamma oil is equal 0.9, gamma water, so is equal 0.9 multiply 9810. Okay, but if I give you raw water instead of gamma water, so I use the same. Raw water is equal 1000. So raw water, raw oil is equal 0.9. Why 0.9? This is 0.9 because I use here 0.9. No one tell me. This is 0.9, 0.9, 0.9. This is 0.9 multiply 1000. So I get raw oil. Okay. For example, SG is equal 101. So 101 multiply gamma water or 101 multiply raw water. Okay. Bulk modulus of elasticity. This also property. Is also property. But refer to what? This property, it is referred to change of pressure to the change in volume. So by to be easy, for one meaning easy, it measures elasticity of a fluid. Elasticity of a fluid. What's the meaning of that? Let's see. If you have two material, two fluid. This fluid, you know fluid, liquid or gas. You have two fluid like this. Okay. Okay. I apply by pressure. Okay. You need to fix it one. You have two parameters, pressure and volume. Should be keep one constant to measure the other one. To can measure the meaning of bulk modulus. So I keep the change of volumes the same. So it means I apply by pressure, but to keep here the volume, make a change of the volume here, delta V. The same change of the volume here, delta V. So here the same change of volume happened. But to make the same change of volume for the, this is we can set A, this is can set B. This required B1 to make this change, but this required B2 to make this change. And B2 is less than B1. So what's meaning of this? What we conclude that? This is conclude, give me as conclusion. What is this conclusion? One of this material is easier to compress rather than the other one, correct?
Yes, sir.
Sure. Which one is easier to compress?
B2. Sorry, B.
B. Why? Because this is actually need little pressure to make the same change of volume, correct?
Yes.
Actually, this is the concept of bulk modulus of elasticity. They give you values. This value is property for the material. When this value is little, than the other value, so it means this related for fluid is easier to compress or more elastic rather than the other. Clear? What is the equation used here? The equation for bulk modulus of elasticity E is equal the change of pressure to the change of volume, but this is not a change of volume. This is delta V over V. Yes, we put the denominator here as a percentage. It means the change of volume to the total volume. So write it here as a percentage, which is mean I needed this part as a dimensionless for denominator to keep this unit for the bulk modulus is the same unit for the pressure. That's it. So this unit is Newton per meter square, which is Pascal, the same unit of pressure. So it gives you the same indication, delta V or delta V or V. Yes, delta V is the value. Delta V over V, and no problem, is a percentage, which is delta V over V here, 10%. Delta V over V here is 10%. Clear this? Let's read this question, please. Bulk modulus of elasticity of ethyl alcohol is 1.06, 10 to the power 9 Pascal. For water, it is 2.15, 10 to the power 9 Pascal. Which of these liquids is easier to compress?
Ethyl alcohol, because the pressure is required is less.
Again?
Ethyl alcohol, because the pressure is less.
Yes, exactly. Ethyl alcohol, because this is required little pressure to make the same change of the volume. Exactly. Viscosity. Viscosity, one of the important property for fluid mechanics. Let's see what is the definition to can understand the equation created here. Viscosity mu, it is a fluid property. It's okay, representing the resistance of the fluid to deformation by shear stress. So the flow is moving like this. Due to the flow moving, what happened? The layer have a shift between layers. Due to what? Due to the lower layer here is contact with the stationary plate, for example. So for sure, this is more resistance with the fixed one. So it's almost zero. The layer contact with this is not moving. And when you go up, the layer is this one is make a friction with the below one. So it is moving, but it's still low. And go up and up and up. When you go up, the layer, it will be more free, so it will be more accelerated. So the velocity here is higher, which is free moving. This is what's describing here for this curve. The velocity here is 0, and the velocity here is maximum for the free one. So we have something is said velocity gradient. You see this distribution is said velocity gradient. So it said what? Velocity gradient. Okay. So this is said what? This is said velocity gradient. This distribution is said velocity gradient. Not all the time is linear like this, but I give you the simple way, because if it is otherwise